Now
This
we'll be
conference will
starting.
now be recorded.
Now we'll be starting with UVM training. So this is the final phase of the language learning. Like we have learned Verilog, System Verilog, and now we are going to learn UVM. Once we are done with UVM, we are going to start with the projects. That will be like AXI verification, IP development, and Ethernet MAC verification, and other things like Linux and scripting. Those things we'll be doing once this is done. This course is going to be important. This UVM training will be important because a lot of hiring that happens. I mean, when as a fresher, when you apply for any job, the hiring decision also involves your expertise with UVM, because they'll be majorly focusing on digital Verilog, system Verilog, and UVM. Once you are all good with these things, what are things? Digital Verilog, system Verilog, and UVM. Then the training will move on to the next stage, that is projects and protocols. So the primary thing for you to be comfortable with is UVM methodology. Now let us understand what is the need for UVM methodology. I mean, what is UVM, why we need UVM, and how to use UVM. So we are going to ask 3 questions. So the first question will be, what is UVM? Then why we require UVM? Then the third thing we are going to ask will be how to use UVM. Okay, so first let's understand what is UVM refers to. See, UVM is basically a methodology which stands for Universal Verification Methodology. What is meant by Universal Verification Methodology means, it is a methodology means what? A set of rules that everyone needs to follow, some guidelines everyone need to follow. That's what we call as methodology, right? So what methodology tells is, any verification engineer, any verification environment that we develop, it will be good to implement that test bench using these common guidelines. So those common guidelines we are collectively calling as UVM. Wait. Hello everyone, I'm sorry for the delay. My laptop is taking a bit of time to start, so hence there is a delay. So in the meantime, anyway, let me continue on the mobile. If not, I will arrange an alternate laptop to do the session. So if you remember, we are talking about the UVM, and we discussed that UVM stands for Universal Verification Methodology. See, what is the need for UVM methodology is, if I take 2 designs, let's say we are talking about one thing called as SPI controller. Let's say we take another design called as DMA controller. So we are talking about 2 designs here. One is SPI controller, one is DMA controller. Let's say both these designs have 2 interfaces each. Let's say that means what? SPI controller has 2 interfaces and DMA controller has 2 interfaces. Now when you set up the test bench, can someone tell me what all components will be there as part of the test bench? Let's say we are setting up a test bench for SPI controller which has got 2 interfaces. One is the interface with the processor, one is the interface with the SPI slave. Now let us say we develop a system Verilog based test bench. Can someone tell me what all components will be there in the test bench architecture for this SPA controller test bench?
Functional coverage blocks are monitors, checkerboard, reference model, register model, uh, BFM, and scenario generators, test cases. We can divide those components, generator components and scenario generation components like this.
Yes. So if you see, if you are talking about SPA controller, it will have various components like BFM, a generator, monitor, coverage, the reference model, the checker, scoreboard, and assertions. Various components will be there. Now, the same way, if you take DMA controller also, some other design. I'm talking about now a different design. So earlier we talked about SPA controller. Now we are talking about new design called as DMA controller. If I take DMA controller, can someone tell me what all components will be there as part of the test bench architecture for DMA controller? Will they be different or will they be similar to what we had in SPA controller?
Similar, sir.
It will be similar, right?
Similar.
And you see, even in DMA controller, we are going to have the same components like BFM generator, whatever we discussed for SPA controller, the same components will be there for DMA controller test bench architecture also. The thing is, when you are going to set up the test bench for two different designs, the test bench architecture does not differ much. That is where we use a concept called as methodology. I will give you one simple example of a methodology. Let's take one simple example of methodology. If let's say I want to construct one house. Okay, I want to construct one house. What I will go to the architect. What architect does is, architect has two options to do. One is he gives me everything from scratch. All the basic things, everything, he starts doing everything from scratch. Otherwise, he has a plan where he will tell, you see in architecture, he will have one option to just place a room. He will have one option to place a bed. I don't know how many of you have seen house architecture diagrams, but you might have noticed that he doesn't draw, he won't sit and draw the lines and everything. He will just place those things because he has those things as part of his library. In his architecture software library, he has some elements called as for drawing a house, for drawing a bathroom, for drawing a kitchen, for everything he has some symbols, and he will just place them, and then finally he gives me the architecture diagram. Can someone tell me which one is beneficial? Drawing everything from scratch is beneficial, or using some already existing diagrams will be beneficial? I mean, he will be using some existing components, and based on that he will develop things. Which one is beneficial? Can you tell me?
Already existed.
Already existing thing will be beneficial, right? Because he doesn't have to spend. What is the benefit if he uses already existing thing? What do you think is the benefit of that?
We can save time, sir.
First is we save the time. What is the next thing? It comes with some guidelines. Basically, that software also gives you some guidelines. If you are trying to do some mistakes, it will correct you. Okay, let's say you have a software which will correct you also. Like, for example, as per the house architecture, kitchen should come in some corner, let's say southeast corner, for example. So if you try to do something wrong, the software will correct you, saying that you have done something wrong. Hello everyone, and now I have joined through my laptop, so I think we can start off now. Let's say I'm talking about one of the architecture, for example. Okay. Let's say we talk about this. So what I'm talking about is, in this, he will have one unit called as this, he will have one unit called as this, he will have one unit called as this, and like this, he will have various units. He just places and creates me a house architecture. That is what UVM does for me. In System Verilog, what we do is, everything we draw from scratch. We have to draw this line, we have to draw this line, we have to draw this line, we have to draw this line. Everything we have to do from scratch. Whereas in case of UVM kind of methodology, these stairs are available. Now, when you are using stairs, you can specify what should be the width, what should be the height, how many steps should be there, like what should be the size, and what all elements do you want, where do you want this. So the his software, whatever software he uses to develop this architecture diagram, he will have some uh, 40 to 50 elements, or maybe more than that, like one to represent a bedroom, one to represent the kitchen elements, one to represent the living room elements, one to represent the bathroom, various things to represent various elements. Let's say for lift, he will have various elements. So what he does is, by using that, he can reduce the overall time that is taken. So let me just quickly make a notes for this. So UVM provides with UVM is a has a so he has a library called as base classes, which can be used to develop the test bench architecture. Whereas if we go with system Verilog, everything need to be everything needs to be developed from scratch. So the simple example is, analogy is what? House architecture plan. Analogy is what? The house architecture plan, where what there are two options. Architect has two options. One is develop everything from scratch. What is meant by everything from scratch? Let's say to draw the room, first he will draw first big layout. Then he has to draw one of the rooms by drawing manually the lines. Let's say he has to place a bed. He has to manually draw the bed, and he has to put all the bed symbols, everything. Let's say for kitchen, he has to put the kitchen symbol he has to develop. This is what would be similar to system Verilog. Is similar to system Verilog. Second is, he has a library. He uses a software which has got which has these symbols, which has these elements are symbols, which he can use, which he can customize and use. Okay, now again, everyone tell me which one is this is similar to UVM. Tell me which one is better, whether developing everything from scratch is better, or using a software which has got elements and which he can customize. What do you mean by customization? Let's say I want this to be some different size, I can use different size. Let's say this room I can customize what is the size I want, this living room what I want size, I can customize everything. So which one do you think is better, the first option or second option?
Second options.
Second option.
Second option is better. Now, do you see any disadvantages? Are there any disadvantages with the second option?
Maybe if there are
Only
similar existed elements, then only we can utilize, sir.
not like that. See, the software will give you everything. See, it will give you everything. Only disadvantages. I mean, I won't even call it as disadvantage. Architect will have to learn. Will have to learn how to use the software. And this is the time he needs to spend time on this, right? He needs to spend time on this. You got it right. So unless he learns how to use the software, he doesn't know how to come up with this structure, how to place it. Let's say he may place it and it may come in this direction. How does he know how to rotate it? So all that, how to specify the sizes. So he needs to learn how to use the software. Now, once he has learned the software, everything is simple. Except for this point where he needs to learn the software, there are no disadvantages. The same thing is with UVM. Same with UVM also. You need to spend a good 1 month time to gain expertise with UVM. I mean UVM classes, UVM guidelines, and how to develop UVM based test bench. Okay. Now let us understand what is the advantage. What is the advantage? Let's say, going back to this diagram, if he starts doing everything from scratch, tell me how much time do you roughly takes? Let's say he takes 1 week time to draw everything manually, because he has to draw this line, he has to draw this line, everything he has to draw manually, because there is no option for he is not using any predefined elements. Like stairs is one element, lift is one element, passage is one element, living room is one element, kitchen is one element. He is not using any of them. He is developing everything from scratch. Let us take, he takes 1 week, assume. Okay. uh, doing everything from scratch takes 1 week time. Let's say if he using the software, how much time it may take? Can you tell me?
Maybe 3-4 days, sir.
1 day it can be done, right? I mean, because if you know what to do, okay, going by the same comparison, it may take 2 days. Yeah, it may take 5 days, let's say 4 days. I'm just giving you the rough estimation. Okay. Thing is, that is what UVM does. So when we develop a test bench using system Verilog, it may take 4 months time. Same work can be finished using UVM in 2 to 3 months time. Now, with no other disadvantages, with no other disadvantages. Now, if you go back to the architect, only other disadvantage I can think of is he has to invest. He has to invest some money in purchasing software, right? He has to purchase software, that will he has to invest. In UVM, we don't even have to do that. In UVM, there is no need to purchase anything. Because UVM is a free source. UVM is open source code. Open source code means what? Anyone can use it. Anyone can download and use it. There is a website called as www.accelera.org or something. From there, download UVM. Clear, right? Now, do you understand why we are moving to UVM? Do we understand what is the advantage of UVM? Why UVM? Why we are using UVM?
Yes, sir.
Everyone, I
Understood.
want everyone to respond saying that yes. If you understood, say yes. Otherwise, say no.
Yes, sir.
Okay, you all have understood.
Yes, sir.
Okay,
I understand.
Yes, sir.
like in house architecture, what all elements we got from the software? What elements did software give us? Can you tell me? Just anything that you saw in the diagram. What do you think? What all elements do you think did we get from the software?
Stairs. Uh,
It gave me living room option. There will be one element called as living room. See, the software will have one element called as living room. What it does is he drags it and drops it here. Then it will ask what is the size. He will tell 13 feet by 12 feet. So it will create one room like that. Then his software will have on the right hand side one option called as sofa. He will ask drag it and drop it. So sofa will come up. So where he can specify how many seats it should be. 3 seats, Then he will have one more element called as kitchen, that the kitchen table, right? He will drag it and drop it here. The kitchen table will come here, and he can specify what all elements do you want in it. So essentially, what happens is the house architecture comes essentially because of it. So like that, the way he has got various elements like the kitchen, stairs, passage, etc. Different elements. Same way, UVM library also provides base classes, something called as base classes. These are called as UVM underscore driver, UVM underscore monitor, UVM underscore environment, UVM underscore test. Like that, various elements will be there. Now, all user has to do is use these base classes, to create the test bench environment without, instead of doing from scratch, instead of developing from scratch. We don't need to develop everything from scratch. Rather, use the existing base classes and just add additional functionality. So that would ensure that you are using the whatever functionality that is coming as part of the driver, and you are adding your own functionality. What is meant by using these base classes? So when we say using these base classes, basically we will be doing inheritance class app driver extends UVM driver parameterized for app transaction, because it has to, app driver has to handle app transaction. So we are parameterizing my driver for app transaction. Now the advantage is what? All the functionality of UVM driver will be part of app driver. You agree, right? All the functionality of UVM driver will be part of app driver because of what? Can you tell me what is this concept is called as in system Verilog? What do we call that concept as? All the functionality of UVM driver is part of app driver. What is that concept is called as?
Inheritance.
That concept is called as inheritance. Because of inheritance, everything that is part of the base class becomes part of my extended class. On top of that, we will add code that is very specific to app driver. That way, what happens is you are reusing existing functionality of the UVM driver, and you are adding a code that is specific to your requirement. Finally, out of that, you get app driver. Now you may be asking, what is driver? Driver is very similar to whatever is app BFM in system Verilog. Same is called as app driver in UVM. We go to UVM, the same app BFM is called as app driver. I hope you all have understood. First of all, why this is important is before learning anything, you should have a motivation. Before learning anything, you should have motivation. Why we are learning something, right? Basically, what is the motivation for learning UVM? What is motivation for learning UVM? Because it reduces my efforts as a verification engineer. As a verification engineer, it reduces my effort. How much? What does it do? Test bench development time is reduced. Or 30% time, whatever, right? Uh, test case debug time is reduced by. Can everyone hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Yeah. So what I am telling is, to learn anything you need a motivation. Okay, what is the motivation for learning UVM? Can someone tell me? Now let me ask one question. So can someone tell me what is the motivation for learning UVM?
Because it has some pre-implemented base classes, so we no need to do everything from scratch, so that we can save the time,
Yeah,
and our
basically what
verification
it does
becomes
is,
easy. Yes, sir.
yeah, our verification becomes easier, test case development becomes easier, test bench development becomes easier, test case debugging becomes easier, everything you do in UVM becomes easier. See, what is the advantage? I'll tell you. uh, Again, I will take this example through that only. I'll tell you this architecture diagram. Let's say I tell him that I this diagram is there. Tomorrow I tell him that I want some change in this, because it is not as per my requirement. Now what he does, he will ask me, what is the change you want? Let's say I tell him that I want bedroom to be here, I want living room to be here, for example, something like that. I tell him. Now if he has done everything from scratch, again he has to cancel these lines, he has to cancel this line, he has to again draw that lines here. Okay, now he again has to move all these things here, he has to draw everything here, he has to draw sofa here, he has to draw another sofa here, all that. Basically the point is, if you develop everything from scratch, it is going to take a lot more effort to do the same work. Whereas in UVM, he just has to move these elements here, he just had to move this element here, this element here, that's all. And he has to define a new room here, something like that. The point is, it reduces effort everywhere. In all the things, effort is reduced, and it doesn't come at any additional cost. There is no additional cost for this whole activity, there is no additional cost at all that is additional is what? Some time you need to spend, like you said, architecture need to spend some time to learn how to use the software, right? You need to learn how to use the software. Same way, you need to spend time to learn, gain expertise with the UVM. That is the only thing you have to do. Once you have done it, everywhere your time gets reduced. What is that it is going to do? How it is going to help you? How this time reduction will help me? It will help me, one thing, because I will get more time. I can do more things in. I can do more things in same time, because I'm able to do. I'm able to do the things in 30% less time. I can use that remaining 30 to 40% time for something else. The other important, more importantly, is the remaining time, the time that is saved, can be used for actual debug of the design. Means, see, the goal of verification engineer is not to learn system Verilog. Goal of a verification engineer is not to learn system Verilog or UVM. Goal is to find bugs in the design. Bugs means what? Some wrongly coded behavior in the design. Now, if you, as you save the time, this can be focused more. So this is what you are really doing the work for. See, system Verilog and UVM is just helping you do this. System Verilog and UVM is just helping you do this. But that is not your goal. Your goal is find the bugs in the design. Find the bugs in the design. Right, to do that, when you set up something using UVM, it becomes easier. Now, has everyone understood? Is everyone motivated that why you are going to learn UVM? How about others?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Okay. Next. Okay. So UVM should be learned from a practical perspective. UVM should be learned from a practical perspective. Now the example is, what is meant by practical perspective is simple. Let's go back to this architecture diagram. Okay, someone is teaching, let's say person XYZ is an architect. He learned the software, but he doesn't know how to draw real architecture diagram. Someone goes to him and tells, this is my house plan, draw the architecture. He only tells me that I know what is house, what is bed, I know what is sofa, but I don't know how to construct the house. Is there any use of such a knowledge? The architect will only tell that I know how to open the software and how to put a how to see these elements. There is no use of such knowledge, right? What he should be capable of, he should be capable of drawing this kind of diagram using the software. So for that you should get used to it. See what happens. Once he will draw first house, he may take 2 days. Second house, tell me how much time it may take. He spent first house 2 days time because he is new to this, how to place this, how to place this, how to place this, all that. He took, let's say, 2 days time. Second house, tell me how much time he may take to draw the architecture. He might even finish in one to
It
one
may
and
be
a
in
half days.
hours.
It may be an hour. Now as he keeps doing third house, fourth house, the 10th house, he will finish it in 2 hours. What he took 2 days time initially to start with, it will take 2 hours time to do the same work when he goes through multiple things. Now you may ask, what is it there for me? I mean, you are talking about architect. What is there as a verification engineer? What is that I need to learn here? Can someone tell me what is that? I mean, what I am trying to infer here? Can someone tell me? Through this example of 2 days to 2 hours time, what is that I am trying to tell to you? Can someone tell me?
Getting expertise how to utilize that pre-implemented base classes.
Yes. So what I want to convey is, initially if I take any design as a verification way, if you start learning, let's say I give you a design, it may take you 3 full days to develop test page, or 7 days, let's say 7 days to develop test page. But as you start with second design test page development, let's say this is for first design, you may finish it in 4 days only. Eventually you will keep coming to a point where when you do the 10th design of 10th design, or maybe even you don't even need to go to that stage, 5th design, you can finish off the test bench in 1 day time. Whole test bench you can set up, you will be able to set up. So this is where you have to be careful. What is meant by careful is, initially you should not get discouraged that, oh, it is taking me a lot of time to do this. Because why it took you a lot of time? Because you are not used to these options. Like, you going back to the architect, he doesn't know how to place the bed, how to define the sizes, how to define the sizes. I mean, he may be doing some mistakes here. He doesn't know how to rotate this sofa position. He doesn't know how to place here various things. He doesn't know how to draw this partition, various things. He may be new to all that, right? Second thing is, he might have missed out few things in the first drawing. In the first house, he may not have got option to draw the passage. He may not have drawn the lift in the first design. In the second design, he might have learned how to draw the lift, okay, how to take care of some lobby, various things, right? Now third you go, then he knows everything. He knows how to draw this, how to draw this, then he can put everything properly. That is what happens to you when you learn UVM also. You don't learn UVM by reading the document. You learn UVM by taking a simple design, and setting up the complete test page from scratch. I mean, from scratch means what? Using the base classes. As you start doing this, you will come to a point where, for a complex design, you will take is 1 day time to set up the whole test page. And it happens with practice only. See, very first time he would have done, he wouldn't take, definitely he can't finish it in 1 day. He will surely take 2 days time. Very first time he has done. Next time, 1.5 day. Next 1 day. Next, he will come to a point where he will finish everything in 2 hours time. So same way, going by that only, our training also will be practical oriented. So what we are going to do is, we are going to take memory example. You remember what we have done in Verilog? We have taken memory and we have set up the test bench memory .v Verilog code, and further test bench setup using Verilog. Then we went to system Verilog. Same design. Then test bench setup using system Verilog. Then we went to, now we are going to UVM. Same memory code. We will set up the test bench using UVM. So idea is what? Because you know what is the design, I don't have to explain everything about the design. Okay. We will be more focused on the learning the UVM through that. Once we are done with this, in the later stage, we'll do complex project. Later stage of training. Clear? Now, tell me, what all new concepts did we learn in Verilog? We are going back 3 months back where you are doing Verilog training. There you remember we have set up a Verilog based test bench for memory. What all concepts did we learn during that time? Can you tell me? How to develop test cases. Then what else did we learn? How to use task functions to make code readable and reusable. Did we learn that? Did I explain that concept to you?
Yes,
Parameters.
sir.
Okay. Concept of using parameters to make code readable. Again, same thing. Then what else did we learn? Tell me. The concept
I
of
think
front door access, front door and back door access. Then what else did we do? How to write code to write to memory, to write and read the memory. How to implement code. Code to write and read memory, read the memory. All these concepts we learned, right? And then we learned how to view the waveform and confirm whether write and reads are happening, write reads are happening. All those things we learned,
we discussed
right?
about macro also, sir.
Which macro? Tell me.
Width.
Yeah, that is parameter only. Okay. Anyway,
Okay, sir.
so these are the concepts we learned. When we went to system Verila, most of these concepts we know. We learned few things new, like how to set up a configurable test bench. What is meant by configurable test bench? Tell me. Multiple agents, a test bench with multiple agents. Do you remember? We have how many agents did we create in our memory test bench in system Verila?
3 agents.
Three agents.
What else we learned? Then how to use
Semaphore.
semaphore. Okay, for a inter-process synchronization. And what else did we learn? How to use interface and clocking block interface for DUT and test bench connection. Then how to use clocking block for synchronization purpose for proper signal driving and sampling.
How to generate
What else?
coverage report.
How to implement the concept? How to use the concept of transaction as an object? Do you remember that? I mean, we implemented class mem transaction. Do you remember that? The
Yes, sir.
advantages of moving to object based handling. What else did we learn?
Coverage report, sir.
Yeah, basically how to do coverage report, basic coverage report, checking how to implement checker logic, coverage for coverage logic, everything we discussed, coverage, all that we discussed. Okay, now in UVM, what we are going to do is we are going to our focus, because whatever we have to learn, actually we have learned. This thing we have learned, these things we have learned. So combinedly, they will all apply here also, of course. So I'm not going to teach everything again. I'm not going to teach you how to use interface, how to use clocking block, how to define a transaction, mem transaction object, how to use a task and function. I'm not going to explain everything again because you all know those things. So my focus will be more on how to use UVM to reduce the time that takes, to reduce the time taken to set up the test. Let us say in system Verilog, let's say in system Verilog, we spent, for example, 6 hours time. I don't know how much time we spent. Let's say 6 hour time. Now, how can we bring this to? How can we bring this down to 3 hours or maybe 4 hours time? Is what is our focus, and without losing anything. See, while reducing from 2 to 6 to 3, we are not going to reduce the quality. We are not going to compromise on the quality of the test page. While having everything same, how can we make sure that we reduce our effort? That is what our focus will be. Okay. So hence, from the day one, starting from today itself, I will be teaching memory and how to set up the test bench for memory. While doing that, so my approach will be, my teaching approach will be initial 1-2 sessions. I will teach memory test bench setup using UVM. Next, after these sessions, let's say I think it might go for 2 sessions. Later, I will be starting with UVM. While doing this also, I will be giving you some UVM basic concepts, UVM basic exposure. Then I will be going into depth of UVM constructs. While learning this whole exercise, just remember this architecture diagram. I mean, what I want to tell is not that I'm not asking you to construct the house. I'm not asking you to draw the house architecture. All I'm asking you to do is just remember that a house architect would use these pre-existing elements to make the whole development of this architecture easy. Same thing you remember. Okay, UVM also will have few things which will make my test bench development easier. Okay. Next, is UVM different from system Verilog? Rather, I would say how UVM is different from system Verilog. Basically, UVM is developed on top of system Verilog. UVM is developed on top of system Verilog. That means UVM is also a system Verilog only. UVM is also system Verilog code only. It's just that pre-implemented. It's just that what is that? It is pre-implemented. What do we mean by that? If I go to one of this code, let's say UVM, any code I take, a UVM source I have here. I think source code somewhere should be there. Let me see here. Yeah, here it is there. So this is what I download from the website. If I go to Accelera, they will give me this either source or source 1.2. It is like a 1.2 version of the UVM. This is 1.1 version of the UVM. You may ask, where is 1.1? It is understood that it is 1.1. This is 1.2 version. So if I go to 1.2 version, it will have lot of lot of directories. In each directory, there will be lot of code will be there. For example, UVM driver will be there. So inside the source, there is a folder called as components. Inside that components, one component called as UVM driver will be there. If I open this, you can see that they will provide me this definition. Do you think is it system Verilog or some other language? This language, what you see, line number 56 and further down, if I see some declaration, some function definition, end class, do you think is it system Verilog or some other language? It is all system
System
Verilog.
Verilog.
So point is what? UVM is no different from system Verilog. It is just that in system Verilog, you have to do everything from scratch. You have to define it. In UVM, it comes as part of the UVM source code. It comes as part of the code. Like going back to this, you don't have to develop this. It comes from the software. Like in software, there will be a bed. You just have to drag and drop. In software, there will be a kitchen element. You just have to drag and drop. There will be a sofa. You just have to drag and drop. Like that for everything, you just have to drag and drop, and finally your house gets constructed. Same way in UVM also, all this definition like UVM driver, UVM environment. Again, you see UVM environment definition is there. Again, UVM monitor definition is there. If I want to implement a AP monitor, I will have to use the UVM monitor definition. And using that, I will be implementing my APB monitor code. So this is the advantage of UVM. Okay. Is this clear to everyone till this point? So what you should be knowing is, what you should understand is, for next 2 sessions, I'm going to develop memory test bench using UVM. And then we will be going in depth of UVM constructs. While I'm going to develop memory test bench, I will be giving you basic UVM exposure. And even if you don't understand, 100%, 100% of things, don't worry. Okay, we will be teaching all those things again when we go to UVM constructor. See, my approach is that I should show you what UVM can do in a simple manner, using a simple example. Then when we go to UVM construct, you will be able to understand it much better. Okay. Next, the labs, how the labs will be planned. Okay, so important thing is, uh, till now, we had Verilog, Verilog projects, system Verilog labs, and mostly in many cases, I believe many cases they would have happened on a dictation basis. In many cases, the lab mentor, either it could be Aditi or Kaushik, whoever it is, or even Abhishek or someone, would have dictated you many times. Would dictate the things. Would have dictated code this, code this. Okay. Now it has to change. It has to change. There won't be any dictation. It's like he won't tell you write a class, write APBBFM, put semicolon, then go to next line, then write end class. This will not be there from now onwards. This will not be there because you are not going to learn anything if they are going to dictate you. Because you are going to learn, you will become a good typewriters. You'll be good for accounting jobs where there will be people, they will look for typewriting jobs, right? There you will be able to do, if that kind of learning we are going to do, where if lab mentor dictates the things and you write down those things, you will become good typewriter. So we don't want to create good typewriters in the institute. We want to create people who are good verification engineers when you are learning SV and UVM. So in that case, what is going to happen? You are going to work on most of the assignments yourself. I am going to teach the thing, and you need to start working on assignments by yourself. And the lab session should be used for, lab sessions should be for getting the support. Let's say you are stuck somewhere, you don't know how to resolve that issue. Let's say you don't know how to make progress with the next step. That is where our mentor will support you. So the concept of they reading out things and you typing should not happen. If again that is happening, means we are going in the wrong direction. Either you are going in the wrong direction or our mentor is going in the wrong direction. So that won't happen. So please keep in mind that you will have to work on assignments independently without even trainer telling that you have to do. And in the lab session, you should be taking the support. Why this is important is because when you go to the job, your seniors in the company are not going to dictate the things. He's just going to tell, this is my test bench, my design is, let's say something, DMA controller. He will tell me this is the document. develop the test bench, or you will say develop the monitor. He's not going to even tell you develop class, APB monitor. He's not going to even read that to you. He's just going to tell you one activity like develop the monitor. You have to get used to it. Let's say you're not used to it, you have to go through the tough phase where you start doing things yourself. Okay, why I'm telling all this important is because I have seen cases where people after all the training don't know many basic things, and my analysis has been that mostly it is because we were training, our lab sessions were happening on a dictation basis where the mentor reads things or teacher tells things, you write down things. That will be stopped from now onwards, and you will have to do things from yourself from scratch, and you should utilize the lab sessions to get the support. Now I hope this is all clear. Now let us get back into the UVM technical aspects. So we are now going to start UVM essentials. So what is UVM essentials and what is UVM advanced? Let's understand. UVM is training is covered in two aspects: UVM essentials, UVM advanced. For a fresher, this is sufficient, more than sufficient. Even from someone from 0 to 2 years experienced, is sufficient. Someone about 2+ years experience, or let's say even if it is 1 year experience and they are good with UVM, they want to learn advanced aspects of UVM, then they can go for UVM advanced training. So for most of you, if you are a fresher, this would be sufficient. This would go for 4 weeks time, 4 to 5 weeks time, or I would say 5 weeks time. This would go for 4 weeks time. So total course will be 9 weeks. Our essentials will be 5 weeks course. So one of the things that we are going to do is memory test bench, UVM basic exposure, and finally what I'm going to do is, as part of that, I'm going to teach you AXA protocol. I'm going to teach you how to develop AXA UVC from scratch. That's also gets included in this. In this 5 weeks, everything gets included. And please be focused. Again, as we know earlier, things move quickly here. Things move quickly. I mean, you by the time you realize that UVM has started, you would have actually completed UVM language altogether. So because if I'm including this also in this, probably in 3 weeks we are going to complete 3 weeks, whole UVM would have completed. So for next 3 weeks, please be focused because it is going to define your chances of getting a job. If you don't learn UVM properly, your chance of getting a job gets impacted significantly. If you learn UVM properly, your chances are much better. Okay. Now let's get back to UVM concepts. All this we can skip. All this we can skip because anyway, I'm going to teach as per the schedule. We know what is UVM. Now let's start with UVM overview. What is UVM? Let's read. Can you read this once? So I hope you have read this. So UVM stands for what? Universal Verification Methodology. UVM is an open source methodology. What is meant by open source methodology? This system UVM files, see these files, what I was talking about. If I go back, these files, you can download inside this system verilog files will be there. If you go here, not here, .sv, everything is SV files. All these are SV files. They can be used directly. User can view the code and use the code without any licensing. It is developed, UVM is developed in collaboration by Mentor Graphics, Synopsys and Cadence. So UVM can be used with any of the simulation tools. UVM is essentially system verilog only. UVM is no different from system verilog. Don't think that UVM is a different language. UVM is pre-implemented system verilog base classes. Next, how UVM has evolved. Let's understand. If you see till 1990s, verification was done using Verilog. Verification was done using Verilog. Since designs were simpler. During that time, designs were simpler. So till 1990s, verification was done using Verilog. With design complexity increasing, Verilog became a bottleneck in the verification process. So Verilog is actually not meant for verification purpose. If you see, verification is not meant for Verilog is not meant for verification purpose. It is mostly meant for design purpose, right? What is the problem with Verilog? Can someone tell me? What is problem with Verilog? Why is it not good for verification purpose? Why is it not good for verification purpose?
Because it's
Can you tell me?
constructs more suitable for design development, sir, not for verification.
Basically, it has got anyone else can give the answer. You have to give this answer at this stage. We have completed Verilog training. We have completed system Verilog training. Now we are in UVM. And if I ask a question, what is problem with Verilog and why is it not good for Verilog? You should be answering. Only one question, one student has answered. Out of 44 participants I have, only 2 students have answered. Is it like remaining 42 students don't know what is the answer also? Don't know what is the disadvantage of Verilog? If that is the case, then it's very bad actually. Okay, many of you may be thinking sitting calm, people will come and just give me the job offers. Nobody will give you job offers. You are not special. You are nothing like any special like Rahul Gandhi or anything, right? You have to earn everything yourself.
Sir, Verilog has less
Putting effort, sir.
constructs.
Basically, one line answer should have been, it has got very few constructs. And these constructs are mostly meant for
Design development.
design coding purpose. Okay. So few things I want to tell is, if you know the answer, you have to speak out. If you go to the interview and just sit calmly, nobody is going to give you anything. Nobody will even give you job also. Okay. So you have to speak and you have to first thing is learn. I don't know why you are not able to answer this basic question. This is a very fundamental question. You should have answered for sure. Okay. Next. So that was the problem with Verilog. So to solve that problem, what happened? Tell me. To solve this problem, what happened? What did industry do? What happened in industry? After Verilog, since they were not able to do with Verilog, what did industry do?
So they come up with
Industry
some
moved
new
to
constructs, sir, for verification.
industry moved to object-oriented programming based languages. Actually, initially it started Vera language. Vera is a language. The object-oriented programming hardware verification languages evolved in late 1990s. In late 1990s, object-oriented programming HVLs evolved. Like we have Vera, like we have Specman. These are the two object-oriented programming languages. They were famous. They were quite famous during 2000 and 2010 timeframe. Then what IEEE thought is, let's standardize the verification languages also. Then they come up with a standard called as IEEE 1800. IEEE 1800 is for what? system Verilog standard as a standard for system Verilog with standard for system Verilog. IEEE 1800 is for what? System Verilog. Can someone tell me what is the standard for Verilog? What is IEEE standard for Verilog? Can someone?
1364.
Yeah, please tell me.
1364, sir.
1364. IEEE 1364 is the standard for Verilog, right? Then EDA companies developed HPL. Why they developed Vera and E? These two languages. Why EDA companies developed? These were developed by Vera was developed by Synopsys. Specman E was developed by Cadence. Why did they do that? They developed these companies to promote their tools. Like when you use Vera language, you must use VCS. Let's say if I'm using Vera language, Vera to set up my test bench, then I must use VCS tool for compilation purpose. Then what happens? What is the advantage for Synopsys? Tell me. So anyone who uses Vera will purchase VCS tool. So their Synopsys revenues will go up, right? So hence they spend that additional effort to develop these languages and methodology. Now, do you understand why these companies develop languages and methodologies?
Yes, sir.
Because
To increase
more
their
people will use that to, when they use that, they have to use their tools, softwares. When they use their software, their revenue goes up. Next, these HVL based test benches have a lot of things in common. If you see, I told you initially what is the first thing I started my session with. You set up any test bench, they have a lot of things in common. All these test benches have a lot of things in common. Okay, so since they have a lot of things in common, they came up with something called as base structure, base template. Like it, that is what we are calling as methodology. So this enabled developing base classes which can be used in every test bench setup. It saves the time in developing the test benches. Saves the time in developing test benches. Because like as I said, example, this one, if you are developing everything using this basic unit, one bed becomes 1 unit, 2, 3, 4, 5, 6, 7, 8, 9, like that. Let's say 10, 11, like that. If someone provides me with these 10 elements or maybe 20 elements, I can use those 20 elements and set up this whole architecture within 2 hours time. Without that, I have to develop everything from scratch. I have to draw this, I have to draw this, I have to draw this, I have to draw each line, I have to draw each line, then I have to draw this line. That will take, instead of 2 hours, it will take me 2 days time. That is where the UVM provided us with some base classes. So for me, base class is like providing this bed is a base class. This lift is like a base class. Kitchen is like a base class. Stairs is like a base class. I just need to use that and define the behavior of that base class. Like I want 3.5 feet here, 6.5 feet here. So I need to define all that behavior. Okay. That is where it saves the time in developing test benches. It reduces the time taken to develop the test benches, right? That is where different methodologies came. What is meant by different methodologies? See, this architect using one software, let's say software one. Do you think all around the world will they be using same software? Let's say you go to USA, you go to UK, you go to some other country. Do you think all those countries will be using the same software everywhere?
No, sir.
No, right?
They use
Different places they may be using different softwares. Eventually, what happened is, then all these people thought, why don't we come up with one single software which is very effective? They finally thought, see, I'm using software one, someone else is using software two, someone else is using software three. Then they thought, why don't we come up with one single software which will have everything that we need for an architecture purpose. The same thing happened with UVM also. People started developing their own architectures. Like one company developed RVM methodology. one company developed ERM, one company developed AVM, one company developed VMM, one company developed OVM, then one company developed UVM. Finally, that UVM is the standard which has got everything, like whatever features that are there in other methodologies, everything is there in UVM. That is called as universal verification methodology. Okay, so point is like, don't think that they are all any different. It is like one software, this like another software, this like another software. This is like the final software which has the features of all these softwares. That is why you are learning UVM. Now the advantage of UVM is what? If you know how to use UVM, you can learn, you can easily work in OVM, you can work in VMM, you can work in AVM, because all their features are there in UVM also. Now can you read this, everyone, please? I hope everyone has gone through it. Only one thing I want to tell is no need to worry about so many methodologies. What you need to understand is all these concepts in these methodologies have gone into UVM. That means if you learn UVM, that is sufficient, because it is superset of all the methodologies, all above methodologies, and lot of concepts are taken from ERM. Specifically, more concepts are taken from ERM. Now, what is the need for a methodology? Let's understand why we need methodology. Like as I told you earlier, you set up test bench for any of these designs. Here I am talking about USB controller, DMA controller, memory controller, SPI controller. That lot of things are common. See, there are a lot of things common. For every interface in the design, we need to develop BFM, generator, monitor, and coverage. We need to develop the scenario and transaction classes. We need to develop the basic functionality of the test bench component, and say it is same across the test benches. You see, lot of things you do for test bench development for these 4 different designs is same. What methodology does is it brings uniformity into the complete verification flow. The way verification engineer do the things, it brings a uniformity. Okay, for example, everything user can think of in functional verification flow and test bench development, the UVM will tell how to do everything. Let's say whatever you want to do, how to set up the test bench, how to develop test cases, everything is part of the methodology. So what all things are there? How to develop test bench architecture, how to develop the test bench components, how to do the test case coding, how to do scenario development, how to print various types of messages, how to check when to end the test, how to report the test status, whether passing or failing, how to connect various components. I think this should have been test bench component coding and test bench component connection, connecting test bench components. Then test case coding, checking the design outputs. Let's say how to check the design outputs. That becomes the next step, right? And when to end the test, and how to check whether test is passing or failing. Reporting test status, all those details, whatever you want to do, the UVM will tell me. UVM brings a uniformity. The advantage is like what? I'll tell you one simple scenario here. Again, going back to this example. Let's say I went to person A. Name of the person is A. He developed me this architecture diagram using one software. Now what happened? For some reason, A is not able to work on this. Then I went to person B. I took this architecture diagram with me. Now he is using a different software. Let's say software 1 and software 2. Tell me, will he be able to use this architecture, or will he have to develop everything from scratch? If he is using software 2, what is the problem? Will he be able to use the existing architecture? Can you tell me? No, right? Because he is using a different software. Because he is using a different software, he won't be able to do that. Whereas if this person was also using software 1 and this person is also using software 1, there won't be a problem. He will be able to work on same thing. He will be able to do the changes. So same thing here. It's like if this person also uses UVM, person A uses UVM, person B also uses UVM, the test bench development becomes a lot easier. Now, if a verification engineer was doing, some other verification engineer need to do the same work, because both of them are using same methodology to do the things. It's much easier for us to maintain the test benches. Are you learning the advantage of what? Do you understand what is meant by uniformity? If a new person comes into the team, if the test bench is based on UVM, if that person also knows UVM, he can easily understand the test bench architecture. Do you agree with that? Because he knows how architecture will be present, how the components will be coded. He knows how the components will be connected, how the test cases will be developed, how the scenario development happens. Everything he knows. That is the advantage of following a common methodology by all the people. So in summary, UVM provides guidelines on how to do all these things efficiently. So let's not, I think these all things we understood, let's not get too much deep into it. Now what I'm going to do is, I am going to develop the test bench for memory. Okay, before that, let's go for a break. We'll take a 15 minutes break. We'll meet at 11:30 a.m. and then we'll continue the session.
Sir,
Yeah.
can I ask question now or after break?
Yes, please. You can ask Darji.
Sir, regarding there is a statement which is given in a magazine that the chip manufacturing industry is going to be become low in future. So there is an
Become
alternative kind of design which is coming in the future part it seems. So how far it is true, sir?
no,
I
chip
mean,
design industry is going to become what?
I mean, it is going to be reduced because the investment which is going for developing a chip is vast, and there is an
No, I will
alternative
tell you one
source.
thing. I'll tell you one thing. After 200 years, world will end. Then what should we do, sir?
No, sir, not exactly after
World will not
200
have
years it
petrol.
won't be there.
World will not have,
But I'm
not even
talking
after
about 1
200
or
years.
2 years,
After
sir.
200, let's do one thing. After 50 years, petrol and diesel will not be there. Should we start crying now? Should we start worrying about that?
Sir, I'm talking about 1 and 2 years time, sir.
No, nothing is going to happen like that. Don't worry. See, don't complicate your things too much. Even if something is going to happen, you cannot do anything. Don't worry too much about things which are not in control. Try to focus and learn what is there you can do. Okay, that kind of things are there in discussion for last 20 years. People have been talking about the same thing. Last 20 years, people have been talking about automation of the flow. People have been talking about flow automation, uh, automated design development, automated test bench development, everything. Nothing happened much. Only probably they made a progress of 5% in 20 years. So the same thing will happen in next 20 years also. Okay. Now, if you still want to worry, you can worry. Okay. There are two things. One is something that is not in your control. You don't have to worry. Just focus on learning and becoming good with what is there. Right. Even if so, you if at all it if at all size reduces by 50%, try to be in top 50%. So that you won't get impacted. If at all, whatever you are saying, it happens, try to be in top 50% of the team. Otherwise, I would say don't worry too much about other things. People will write 100 things. People will say after in 2025, world will end. World War III will come and nuclear war will happen. Will we stop worrying and will we stop crying now? No, right? Let's not get too much into it. Okay. So point is what? It has been there, that kind of news has been there. So my suggestion is don't worry too much about it. Just focus on what you are learning now. That will be good for you. Okay. Everyone, let's meet at 11:30.
This conference will now be recorded.
So now what we will do is we will be developing the memory UVM based test bench. UVM. APB UVC template. Here I have, let's say, memory code. Somewhere I have memory code. Let's otherwise do this here first. Memory test bench. I will copy memory from here. So I just, if you see, all I have done is I just copied the design. And the other thing I'll have to copy is source. I mean UVM source code, which I don't need to copy. I can just use the path. Now, what we are going to do is we are going to take this design. We are going to develop the whole test bench in UVM. Okay, things will be a bit quick and will be a bit fast. So don't worry about that. Even if you don't understand a lot of things, don't worry, because we are going to explain everything from scratch again. So first thing, it starts with is developing the top data stream. The way in system Verilog you develop top test bench, right? Here also we'll develop, let's say, top test bench data stream. What do you do in the top test bench? The very first thing, whenever you work in UVM, the very first thing you have to do is include UVM package data stream. Do you remember what I'm talking about here? 1 week back we have already talked about this. When did we talk about this concept? Most of you are attending, who have come from System Verilog would know what I'm referring to here. Can you tell me what am I referring to here? While I was teaching packages in System Verilog, I told you that all the UVM code will be given as a UVM package. You have to compile that package. You have to import everything from that package. Do you remember that, everyone? Right, so that is what we are going to do. So this is the first thing, I mean, a compulsory thing to do in every UVM test bench. This is something you must do in every UVM test bench. The next thing would be common module top, or you can write top TB and module. Now can you list down what all things typically we do in system Verilog environment? Can you list down all the things we do in system Verilog environment here? If it is system Verilog based test bench, what do we do?
We write class, we write top module.
So I hope you remember what we have done in system verilog. What we have done in system verilog is I go here. In Pop TV, what did we do? We included all these files. Okay. Here also we have to do the same thing. Here also we will do, but just that we haven't developed everything. I'm not right now. I'm not including, but eventually we would include everything. Okay. The next thing we have to do is what? Tell me, do I need to generate clock or not? Is this required or not? Can you tell me? In UVM, will there be need for a clock or don't we need a clock?
For object level transaction, we no need, sir.
Yeah, please tell me. It is required, right? It is required. So this code I can take. Next. Do we need interface in UVM? Tell me. In UVM test benches, do we need interface? Even in UVM you require, right? Things are not going to change. So I'll keep this here. Tell me, do we need to generate clock and apply reset? This part will be required in UVM or not? I mean, the way we did in system verilog, do we need to do this in system UVM or not? Tell me. We have to generate the clock and we have to apply the reset. Do you agree with that or not? Required, right? So I have to copy line number 15 to 24. Why 9? Then I have generated the clock. I have applied and released the reset. End. So what I have done? Declared the clock and reset. Instantiated interface. Generated clock. applied and release the result. Okay, till this point is everything clear? The next. This right now it's not required. For now we will keep it. Okay, and now this part will need to be changed. This dollar finish UVM not required. UVM has a automatic process, automatic way of deciding when to end simulation. User don't need to call, but for now I'm just keeping. Okay, understand, this will be one difference. You write down somewhere, you write down. So what is the differences in UVM? No need to call dollar finish, or no need to call dollar finish. It gets called automatically. Next. Okay, next. Well, do we need this in UVM based test bench? DUT instantiation, do we need it? See, I think I have to show you one diagram that will be more easy for you to understand. Basically, this is the diagram we are going to develop. Actually, this is the architecture diagram we are going to develop. This is the memory test bench. So for us, this is the memory. This is the environment we are developing. It has got too many colors. Don't confuse with too many colors. You see top module. Below that UVM root. Below root APP test is there. Below that APB environment is there. Below that agent will be there. Below agent, various components will be there. Can you just spend 2 minutes and understand this diagram? So this is what we are going to develop in next half an hour. For next 30 minutes, we are going to develop this architecture diagram. Please take a look at this once, everyone. I hope everyone has gone through this architecture diagram. So basically, we are developing now top module. As part of top module, we need to instantiate the DUT. For me, DUT is the memory. Now tell me, do we require this code in our UVM test bench? Can everyone tell me? Do we require
Yes,
this?
it is required, sir.
It is required. So
Required, sir.
line number 32, Y10. Copy pasted. Okay, I copy pasted that code. Now, do we require program block? If I show you this is the program block. If I go to this architecture, is there any program block here?
No,
Program
sir.
block is not there, right? You don't see any program block. That means this will not be required. This will not be required. Then instead of that, what is there below the top module? Tell me. In this diagram, what do you see is below top module? One is memory, one is interface. What else is there? Below green color box, which color box is there?
UVM root.
The purple color, right? The purple color is what? The UVM root. So we have to do UVM root. So how do you get that? UVM root means it is the starting point of the test bench. Like for a tree, what is why the name root is? If you take a tree, right? Roots will be there down, right? This is the starting point of the tree. This from here only tree grows. Same way, root is the starting point of the entire test bench. To signify that, they have given a name as root. Do you understand why they have given the name as UVM root? Everyone? Does everyone understand why the name UVM root is used? Because this is the starting point of the test bench. That's why they have given a name as UVM root. So now how to take care of that? Very simple. All you have to do is write initial beginning. All you have to do is run test. Then you may say, where is root here? Where is UVM root here? It is inherently present. I mean, even if I don't define, what happens is if I open the source code base UVM root, UVM globals run test will be present here. This is a global task. Global task means what? Task defined in the global scope as part of UVM library, defined in UVM library source code. So if I go here and check, it's very fancy. This is the code you are calling right now. Can you see root getting instantiated? Can everyone see the UVM root getting instantiated as here? What is the instantiation of UVM root here? What is the instantiation we have given to the UVM root? What is the instantiation we have given to the UVM root? Top. You can see line number 39, top. UVM root is instantiated as top. And then top is being created here. Now you may say, what is CS get root? Don't worry too much. Just understand that top is it's like similar to top equal to new. Means we are allocating memory. Then on top we are calling the run test and we are passing the test name. The run test should get test name as an argument. So what I'm going to do is when I'm going to do here, I'm going to pass a test mem write read test. What I'm going to do, my test name will be memory write read test. Mem write read test. So do you understand what does this does? This is like a run test defined in the global scope. Where is global scope? Here. This is where that run test is defined. So when you call this, all this thing gets executed. So as part of that, root gets instantiated, the root gets created, and the root run test gets called. This is all happens. You may say, instead of this, can I do something like this? What else I could have done? I could have copied all these 4 lines. I could just keep it here. Remove this. That's also same. Now tell me, which is easy? Writing 5 lines is easy, or writing just 1 line is easy? Tell me. Option 1 is easier, or option 2 is easier? Tell me. Which one is better? Option 1 is easier, right? That is why people don't write everything here. Rather, they just call run test, and that run test will do everything for us. Clear, right? Now you go to interview. Someone asks you, what does run test does? Can you tell me what does run test do? Run test called in initial block. Can you tell me what does run test do? What calling run test does? Can you tell me 3 points it does? 3 things happen. What are the 3 things that happen? Tell me. What does it do? Just now we discussed, you should be able to explain this. You should tell that UVM root instantiated as top. Top is created. Then top.run test is called. Test name. These 3 things you should be able to tell. Next. So I hope till this point it's clear. That's all. I mean, this is all you have to do in top TB. Have you understood? You see, 90% of the things are same between SV and UVM test bench. Do you agree with that? Between SV and UVM test bench, SV and UVM top module coding, 90% things are common. Do you agree with that? Yes or no? Right?
Yes, sir.
Now, next thing I'm going to do is in system verilog, what I would have done, the next thing, I would have developed the interface. See, in system verilog, had it been system verilog, I would have developed interface. Then what I would have developed? Tell me, once interface is done, what I would have developed? What is the next thing I would develop as per this code? If you see this code, what is the next thing I would have developed? Because I need to develop all my sub components, right? Below top module, whatever is there, I need to develop everything. What is that I would have done?
UVM roots.
I have to develop memtb. See, in system verilog, I would have developed memtb. So similar to that, okay, first thing, let's develop mem interface. So I don't need, there is nothing to develop because mem interface is already there. I will just save it here, mem interface.sp, because already developed, you know how it is developed. So it is done. The next thing is in system verilog test bench, the next thing we did is we developed the test bench. Do you agree with that? You remember, right? When we developed memory test bench, we developed memdb, then we developed memory environment, then we developed memory agent, then we developed membfm, mem generator. Do you remember that what I'm talking about? That is why I told you that time understanding memory test bench is very important. I told you one statement also that time. If you can develop at when the time when we developed memory test bench in system verilog, I told one statement. If you know this, if you know how to do, your 75% of training is completed. That is what I meant. I mean, if you know how to develop memory test bench from scratch, okay, then you know your 75% of your training is completed. Okay, tell me, let me understand now. How many of you are confident to about this activity? Can you tell me? I want to see how many of you are confident about developing memory test bench in system verilog. You can say yes, I am confident. Yes, you can say yes. If you are confident, please reply yes. Let me see how many people have confidence in themselves at least. Out of 40 people I have or whatever, I want to see how many of you will reply that are your confidence about developing memory test bench in system verilog. I got only 15 responses so far. That means is it like only 40% of you know how to develop test bench, remaining 60% haven't learned anything in system verilog training? How about others? I got only 17 responses. That's not even 50%. And you know what? We spent almost 3 months for system verilog language training only. You know, right? Close to 11 weeks or something we spent. What about I got only 17 responses so far? How about another 22 people? Okay, fine. I can't really help much here. If you don't respond, I can't help much here. So all I want to tell is take activities seriously. Sometimes when I would have told this exactly in the training also, I've told you, if you can develop memory test bench all by yourself, your 75% of the training is completed. Because when I'm going to teach this, you will not find any complex data, because now you will not see any problem in understanding this code also if you have developed by yourself. Okay. Anyway, let's now see what is the next thing I have to develop. Next thing is I don't need to develop UVM root. Can you tell me why? When I'm developing the next step in UVM, I don't need to develop UVM root code. I don't need to develop UVM root code. Can you tell me why? Can someone tell me why I don't need to develop UVM root code? The UVM root is getting instantiated, but I don't need to develop UVM root code. What do you think is the reason? What do you think is the reason why we don't need to develop UVM root code? Even though it is used, it is being used, but then why we don't need to develop that UVM root code? I mean, I don't need to develop UVM root dot svh. No need to. Why? Can you tell me?
because we instantiated package. Yeah.
Because it is already defined. This file is already provided by UVM source code. So no, hence no need to develop. Now that means what? Since it is already present, what do I need to develop? Tell me. If I already have UVM root, what do I need to define now? I already have the definition of UVM root. Then that means as per this diagram, what is the next thing I have to develop?
APB test.
APB test. Now why we are developing APB test? My assumption is that this interface is a memory interface. This is a APB interface. So I can even call it as APB test or mem test. I'll call it as mem test. Let's say. So I am going to next develop mem test.sv. So I will call it as class mem write read test. The name of the test is mem write read test. Extends UVM test. See, this is where UVM comes into picture now. The point is, anything you want to develop, you always extend it from the base class. Let's say I want to develop memory write read test. I'm extending it from the UVM test. Next. Very first thing, see, anytime you develop any component, there are 5 guidelines you have to follow. 5 guidelines to follow. Something you have to memorize. You need to memorize this. You need to memorize this. What are those things? First thing is register a class to the factory. First guideline is what? Register class to the factory. Now you may be wondering what is meant by register, what is the factory, what is the class. Right now, just understand that we have to do it. Eventually, as we go forward, I'll explain you. Right now, remember that we just have to do something called as UVM component utils mem right read test. So this is called as we are registering this definition to the factory. We are registering this definition to the factory. The next thing is instantiate any subcomponents. Actually, the second thing, first thing would have been instantiate any components. Instantiate the children. What are the children? Can you tell me? For as per this diagram, for a test, what are the children? For APB test, who is the children? As per this diagram, who is the child of APB test? As per this diagram, environment, right? So all I have to do is I have to instantiate memory environment. Here, I'm instantiating what whoever is my children, I instantiate them in myself. Second thing is register it to the factory. The third guideline is define function new. Function new definition. So function new definition will be function new string name UVM component parent. Right now I won't use anything in function. Let's not even do this thing. Super dot new name command parent. Now you may be wondering what is this name? What is this parent? Uh, how many arguments does this function new has? Can you tell me? How many arguments are there for this function new? Two. One argument is the name, one argument is the parent. Let us understand the logic behind this, why we need this. Let's understand the logic. The logic is logic behind two arguments. See, I'll give you one simple example. We'll take an analogy. Imagine, take a family, consider a joint family of 50 members. Now, for each member, if I tell the name and the parent's name, if I tell for each member of all 50 members, if I tell the name and parent's name, can we come up with family tree? Can we come up with entire family tree structure? Is it possible? Can you tell me? Let's say one person Ramesh is there. For him, I tell that what is his father's name or mother's name and what is his name. Let's say one more person Suresh is there. I tell what is his father's name and what is his name. Like that, all 50 members in the family, I tell the name and the parent. Can we come up with the family tree? Imagine, take 1 minute time and tell me, would it be possible for us to come up with the family tree? How about others? Can you tell me? Is it not possible? Why is it not possible? See, if I tell, let's say, imagine myself, it is possible, right? It is possible. Let's say my name is there, Srinivas, my father's name. My father also, we have given a name and he has a father. Okay, his father's name. Let's say I have a sister. My sister is, let's say, she gets linked to my father. So that way this tree gets created, this link gets created. Let's say my sister has a daughter, so her link gets created. because for my sister's daughter or nephew, whatever, right? We have given a name and we have told who is the parent. Now, do you think are we not able to create the tree, family tree? Connection. That's why parent name is what gives the connection. The parent's name is what is giving the connection. If you don't give the parent's name, then we can't do connection. Because we are giving parents name, we can easily come up with these connections. Do you agree with that now, everyone? Now tell me, can we come up with the entire family tree? It is possible, right? It is possible to come up with the entire family tree. So that is what UVM also does. In UVM test bench also, for every component, we specify the name and the parent. What is the name and what is the parent? So that is what we are, when you define the new, when you call the new, you give the name of the component and you tell who is the parent. Let's say I'm going to create test. I'm going to tell what is the name of the test, who is the parent of the test. For every component in UVM, if you do that, at the end of the day, you would have given all these details, name and parent. Then UVM can come up with entire bench structure. Has everyone understood why we are passing two arguments, name and parent, as part of function new? Has everyone understood? Please say yes if you understood. If you didn't understood, please say no. Okay, good. Let's move on to the next step. So this is the function new. This is the third step. The fourth step will be define other functions, define other common UVM phases. UVM comes with standard set of phases called as build phase, connect phase, end of elaboration phase, simulation phase, run phase, extract phase, check phase, report phase. See, for now it may be looking complex actually. If I'm telling you so many things, it's definitely confusing. Let me say, if I'm telling you build phase, connect phase, end of elaboration phase, simulation phase, run phase, extract phase, remembering this itself is difficult actually. So, but eventually you will realize that this is easy actually. It's not going to be so much difficult. Just read this once, everything. I will explain you what is the significance of these things. So, as I told you, these are 8 phases that you have to develop in every UVM component. Remember that any UVM component you are going to develop, let's say UVM APB driver, APB monitor, APB coverage, APB sequencer, APB scoreboard. these are 8 phases you will be developing. Sometimes you may skip something because if it is not required, you can skip. If some of these phases are not required, some of these are not required, you can skip coding them. Now, which one to skip, when to skip, we will learn as we go forward. Right now, let's not worry too much about it. So the next thing is what? Define other common UVM phases. In fact, that means only 4 guidelines. 5 guidelines. The 0th guideline would have been extend from the base class. In this case, the base class was UVM test. For example, this line I am talking about. So going by that way, this would have been the first guideline, this would have been the second guideline, this would have been the third guideline, this would have been the 5th guideline. So you remember that everything we are going to develop in UVM, we will follow these 5 guidelines always. So the next thing I'm going to do is function void build phase, UVM phase. Okay. One thing I want to tell is it is just a matter of 1 week time. You will get used to this syntax. Like you started learning system Verilog. Initially, you felt difficulty. You don't know what is meant by extends. You don't know what is function new. You don't know what is randomize. Like lot of things were new. Here also, these all things are a bit new. But eventually, after 1 week, you will get used to it. You will know that what is meant by build phase, what is UVM phase, everything. You'll get used to it. Here, what do we do in the build phase is create my children. Tell me who is my children for test. Who is the child for a test? Who is child? Can you tell me, everyone? Please write it in the chat window. Who is the children of test? Okay, so tell me who is the child of environment, right? I have to do env equal to new. Tell me, I'm doing new. Tell me what is the mistake here? What is that I'm missing here? Can you tell me? When I'm doing env equal to new, what is that I'm missing? When I do env equal to new, what
Arguments.
do you think? I am missing name and parent. I am missing the name and parent. So I need to specify the name. Generally, I'll give env itself as the name. Who is the parent for environment? See, if for test, environment is child. For env, who is the parent? Can you tell me?
Test, sir.
Test. Test. How do you refer test? It is referred using this. We use this keyword to refer to it. When you are inside the test, to refer to this, we use this keyword. That is the reason you will always see this kind of code. You'll always see this kind of code. Okay. Is everyone clear with this? Next is we are done with this one. What we do in UVM is there is some going forward. You learn one new concept called as instead of new, we have to use something called as memory environment type ID create. Now you may ask, this is very complex. Just remember that instead of new, we will do this thing. Basically creating environment using factory definition. Creating env using factory definition. We are creating the environment using factory definition. If that we do that, then we don't need this line.
Just remember that instead of new, this one word, we are using this. You may think we are complicating it, but that's the right way to do. I mean, going forward, there you will see that it has got some advantages of doing it. There are some advantages of doing that. That's why we are doing. So environment is a class. Below that, there is one more class called as type ID. Below that, we have a create method. So we are calling the create method. Okay. Clear? So this completes the environment. Then for me, connect phase is there, right? Connect phase is there. End function. There is nothing to connect. See, connect phase is used to connect my children. Connect phase is used to connect phase is used to connect children below me. Okay. But if I have one children, if I only have one child, if I have one child, do I need to, is there anything to connect? Can you tell me for test, how many children are there? For test, how many children are there? Only one child is there. Now, if there is only one child, is there any need to connect? So if I have two children, I have to connect both of them. That this is your brother, this is your sister. I need to establish that connection between them. If there is only one child, do I need to do any connection between them? No, right? So hence, connect phase will not be required. Since I don't need to connect, so hence, connect phase is not required for APP, mem test, mem writing test. Since there is nothing to connect below me. So then once connect phase is done, what is the next phase? Can you tell me? After connect phase, what is the next phase? Can you tell me? Once we are done with the connect phase, what is the next phase? End of elaboration phase. What is the next phase? End of elaboration phase. So all I'm going to do is end of elaboration phase. I can use end of elaboration phase. Right now, I will just explain. Once the connections are done, if you want to do some final changes to the test bench, you do it. Right now, what I'm going to do is I will use that to print my test bench structure. Print topology. Print topology. Other than that, we don't need to do anything else. Right now, we will stop the coding of test here. We will only develop memory environment and we will move further. Now, again, when you are developing memory environment, you have to follow these 5 guidelines. Can you tell me what is the first guideline? I told you, whenever you develop any UVM component, you have to remember 5 guidelines. What is the first guideline I said? Let me go here and show you. Tell me, what is the first guideline? Okay, Mustafa, if it is empty, no need to code it. The point is, if the connect phase is empty, no need to code it. If connect phase is empty, no need to code it. Next, what is the first guideline? First guideline is that extend from the base class. What do you think is the base class for memory environment? Can you tell me? For mem environment, what do you think is the base class? It will be UVM environment. Like for mem driver, base class will be UVM driver. For mem monitor, it will be UVM monitor. So you just have to use UVM underscore environment. Next, what is the next guideline? Can you tell me? Can someone tell me what is the next guideline? What is the second guideline? You can speak and tell. What is the second guideline?
Instantiate
Children class instances.
Who is my children? I'll go to that architecture diagram. instantiate the children. For environment, who is the children? I will actually, this is called as agent. This black thing is called as agent. Tell me, who is the children for me? For environment, who is the children? Agent is the children, right? Agent is the children. So I'm going to keep APB agent, agent. Clear? Till this point, everyone is clear? Any questions? Next, third guideline. Tell me, what is the third guideline? You have to register it to the factory. Instead of this, tell me, what should I replace this with? Can you tell me? Instead of this mem write read test, what should I replace this with? Everyone tell me, what should I replace it with? I should replace with mem environment. Next, what is the fourth guideline? Tell me. You can speak and answer also, or you can type in the chat window. What is the fourth guideline?
Function new definition.
The function new definition I have to do. So I'll copy this function new. These 4 lines I'm going to copy. I'll just use it here. Clear? Function new, this will be common. This won't change at all. So this is like you can memorize these 3 lines. Next, what is the fifth guideline? Can you tell me? Let me see how much you can remember from my previous session, previous topic. What is the fifth guideline? Can you tell me? Define
Phase connections.
UVM common faces. What are the, how many common faces are there in UVM? 8 common faces are there. So the first thing I am going to do is what? Build phase. What do I do in the build phase? Can you tell me? Can everyone tell me what do I do in my build phase? What will I do in my build phase? Let's say I am there. What will I do in my build phase? In my build phase, I will create my children. So let's say I have 2 children. I will be creating both of them. So I will create my children. For environment, how many children are there? For environment, how many children are there? One children is there, right? What is the name of that child? What is the name of the child? Agent. So all you have to do is instead of env, just use agent. Here also, since the name of the class is mem agent, agent. This is not required. Isn't it clear? I mean, it's simple, right? It's not very complex, actually speaking. If you see, it's not complex. If you follow the basic concept, it's not very complex. Now the next question comes: do I need connect phase? Here in mem environment, do I need a connect phase? Can you tell me it is not required? No. Why? Can you tell me why it is not required? Because only one child is there. If there is only one child, there is nothing to connect. Correct, right? So I don't need connect phase. Again the question comes, do I need end of elaboration phase? Again, answer is no. Reason is whatever test bench structure, see, I was using end of elaboration phase to print the test bench structure. This is used to print test bench structure. It is used to print test bench structure. Since anyway you are doing it in the test case, we don't need to redo again. See, since we are doing in the test, no need to again do in the environment, no need to do it in agent and everywhere. As of now, this much will be sufficient. Now the question about run phase and other phases, they are not required in environment. I will explain why is it so. I'll explain as we go forward. As of now, don't worry about this. I mean, don't worry. I will explain to you why they are not required. The reason is something similar to this. See, why we don't need connect phase? Because there is only one child. So similarly, in the same way, Run phase and other phases are not required. What do you mean by other phases? I'm referring to these things. Extract phase, check phase, report phase. These phases will not be required. These phases will not be required, are not required. Now, why they are not required, I'll explain as we go forward. Because I don't want to teach too many things and confuse you. I just want to keep my explanation to a simple thing. Okay, this is about memory environment. Now I'm done with memory environment. What do I have to develop below memory environment? Tell me. Who is the child for memory environment? For memory environment, who is the child? Agent is the child. So I have to develop agent. I have to develop the agent. See, for I have developed blue box. I have to develop the black box, which is agent. So I'm going to develop memory agent. Now I'm not going to type the this thing. What do you say? My guidelines. You have to tell me. Tell me what should I do? First guideline is what? How many guidelines I have to follow? 5 guidelines. Right? What is the first guideline? Tell me. Class mem agent extend from UVM agent. Simple. What is the second guideline? Tell me. What is the second guideline?
Child instances.
Child
Children,
instantiation.
right? I need to define my children. Who are children? For agent, how many children are there? Driver,
4.
sequencer, monitor, and coverage. So how many children are there? 4 children are there. So I have to define 4 children. So mem driver, PRV, mem sequencer, SQR. Now you may ask, why are you not coding like sequencer? Now which is easy? Mem SQR is easy. The first line is easy or second line is easy? Tell me. So that's the reason. Don't think that you can even write this way also, but we prefer this one because it's easy. See here, already spelling mistake I have done. I have already done a spelling mistake. So to avoid that, we go in a simple notation. Then I can have mem monitor, mon. Then I can have mem coverage. We are done with the second guideline. Can you tell me what is the third guideline? What is the third thing I have to do? Tell me.
Uh,
Factory registration.
Factory registration. I have to register it to the factory. So what is factory registration? This one. Mem. What is that I should write here? I should write driver or what should I write? Can you tell me? I should write mem agent. Clear till this point? Next, what is the fourth thing? Can you tell me?
function new definition.
Function new definition. See, I have been repeatedly just copy pasting same code. Instead, what I'm going to do is I'm going to keep something called as mem common file. In that, define new component. Tell me, what am I doing here? Can someone tell me? In these 4 lines together, what I have done? Can you tell me? These 4 lines together, what I have done? No, what is that I'm doing? I'm defining a macro. Okay, what is the name of the macro? I'm defining a macro. What is the name of macro? What is the macro I'm defining? New comp means the new for a component, new definition for a component. And how many lines that new definition is present in? In how many lines is it present in? We have discussed this concept just 1 week ago in System Verilog. How many lines that new definition is valid for? It is valid till here. I told you, right? You don't remember I have used backslash. I have explained you backslash in the previous session also. Still people are telling only one line. How do I tell? Then how do I teach? Tell me. How do I teach? If you can't remember what I have taught you 1 week back, how can I teach you? Tell me. Exactly the same thing I have told you. I have shown you backslashes also, and now you are not able to even remember. How can I teach you? Tell me. This new definition is spread over these 3 lines. So whenever I use here, instead of these 3 lines, if I just use new comp, it is exactly same as using these 3 lines. Clear? Next, what is the 4th guideline? Tell me. I'm going to remove all the spaces and everything. Tell me, what is the 5th guideline? I think we are done with 4th guideline. What is the 5th guideline?
Define common phases.
Different common phases. What is the first common phase I have to do? Tell me.
Build phase.
Build phase. What is that I do in my build phase? Can you tell me? Tell me, what will I do? Create my children. Tell me, how many children do I have? Tell me, how many
4.
children do I have? 4. So all I have to do is 4 times I copy pasted. Replace this with drv, 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 sqr, 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 monitor, 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 coverage, coverage, coverage. Done. Build phase is completed. Now you may be thinking, why am I complicating it so much? It could have been much easier with this, right? Naturally, you will think that way. But with all that complication, if I am doing, there is an advantage I get out of it. If I am complicating something, there is an advantage. Because of that only, I am complicating it, right? So that I don't want to explain now. In the later session, I'll explain it. Okay. So now the next question comes: do I need connect phase? Tell me. If I show you this architecture diagram, seeing this architecture diagram, tell me, do I need connect phase?
Yes.
Yes. How many connections are there below the agent? How many connections do you see? How many connections
4.
do you see? Tell me, how many connections do you see? Do you see the 2 connections here? So we have to do 2 connections. So we will be doing 2 connections. What are those 2 connections? I will keep here connect phase. See, thing is, the way I am doing is, if required, I am coding. If it is not required, I am not coding at all. If it is not required, I will not even keep it. I will not even keep it. But if it is required, I'll keep it. So what do I do here? I have to establish the connection. Now tell me, the first connection is between whom and whom? The first connection, let's say this is the first one, is between which component and which component?
Sequence to driver.
Sequencer and driver. In this case, just remember that the connection is always done in such a way that master will be the outside, master port connect to the slave port. Is the connection mechanism. Now you may be wondering, what is master, what is port, what is connect. Just for now, understand that my master has a port. This is called as a port. This square box is called as a port. This circle is also called as a port. Both of them are being connected. See, can you see the connection between those 2 things? This port belongs to driver, right? So driver dot port connected to the sequencer dot port. So this will be done like this. See, what is the master? Driver is the master. Sequence item port connected to the sequencer sequence item export. Maybe we should use export here, export or something like that for now. So this is, I'm commenting it because just I was showing you how to do this. This is the actual code for that. So driver sequence item port is connected to sequencer sequence item export. Okay, so now ideally speaking, I should do monitor to coverage connection also. But right now, I'm not going to do that. I'm just going to keep it commented because I'm just trying to keep the things simple. Once we know how to do monitor sequencer and driver, then we'll move to the monitor and coverage later. Okay, now tell me what is pending now. Other than this, what is pending now? Can you tell me? I need to develop driver and sequencer. So first let me do the simple one, sequencer. Just one line code, type def UVM sequencer. Did I use AP mem transaction? Mem sequencer. That's all. Coding a sequencer is very straightforward. Just this one line. See, we are parameterizing UVM sequencer with mem transaction that we are defining as a class because I used as a type def. So this becomes a data type. This becomes a class definition. Means this is nothing but UVM sequencer parameterized for memory transaction. Simple. We are done with memory sequencer coding. Now we have to develop mem driver. For memory driver, the code is very similar to mem-bfm. Remember in system verilog we developed mem-bfm code. The code is very similar to memory bfm. So we are going to develop the same thing. So how do we develop? So I'm going to do what? Here I'm going to get mem-bfm. I'll just keep it open for now. Okay. First thing is again follow the same guideline. What is the first guideline I have to follow? Tell me. Class mem driver extends from where? Can you tell me? Where does it extend from? UVM driver, and it need to be parameterized for mem transaction. For those who are new to this, you will get used to it. Don't worry about it. You will get used to it. Now you may be wondering why you are parameterizing. We are parameterizing because my memory driver should handle memory transactions. We want it to handle the memory transactions. So hence we are extending it from UVM driver and parameterizing it for memory transaction. Can you tell me what is the second guideline? Children, right? Can everyone tell me what is the second guideline I need to do? Child. Who is the child for me? These two things are the child. I mean, these all things instantiate I need to do. So y2. Next. What is the third thing? Can you tell me? Third thing, what is the third thing we used to do? Can someone tell me? The third thing we do is factory registration. Factory registration and function new. We are done with that also. Tell me, what is the fifth thing we do? Can you tell me? Build phase. Now, do I need to create any of my children? Build phase. Now, question is there any child? Do I need to create any child? Do I have a children? Does memory driver has any children? Answer is kind of partial yes and partial no. I have to create virtual interface because if I don't create, it doesn't have memory, then it won't work. I need to allocate memory to VAF. So what I have to do is I'll go here. I'll copy this code. All I have to do is for now, I'll just get it from like this. There is a different way to do it. I'm just getting interface handle to XMR. XMR means what? Cross module reference. Through the top dot pif, I'm getting the handle. Then do I need connect phase? Can you tell me? Can you tell me, do I need connect phase? And one more thing, I have to change it. Yeah. Many times you do such mistakes. You copy paste and you forget to change it. There the things go wrong. So please be careful whenever you are doing copy paste. Be careful. Can you tell me, do I need connect phase in memory driver? No, I don't require, because there is nothing to connect. See, there is nothing to connect, right? See, I have one child as TX. This is not a child. In fact, this is not a child. Not a child. Just an instantiation of transaction. We cannot call transaction as my child. My child should be a component, right? In fact, VAF is also not a child, because I require for the functionality of driver, it's there, but it's not a child. Okay. So answer, can you answer this? Do I need connect phase? Do I need to code connect phase? Can everyone answer this? Answer is no, I don't need to code connect phase. Next is what? Same thing. See, for now, just understand that end of elaboration phase is not required. Simulation phase not required. The start of simulation phase. Start of simulation phase not required. Here, what it is really requires is the task run phase. Someone is asking a question. Why memory transaction is not created in build phase? Memory transaction is generated, is handled during the runtime. Handled during runtime. So hence it will be created in during run phase if required. It is, we don't need to create in the build phase. I only create the components during the build phase. See, mem transaction is not a component, it is an object. So hence you don't need to create it. Now in the task run phase, I'll tell you one very simple thing. I just copy paste this code. You see, I just copy paste this code. Y4. Only one thing will differ. See, we don't have mailbox here. So instead of this line, understand, instead of getting from the mailbox, I will use something called as sequence item port get next item transaction. Means whatever we call as transaction in system Verilog, we call it as item in UVM. Whatever you call it as transaction in UVM, you call it as item. Okay, so this will be replaced. Live transaction. Instead of this, what I have to do? Next thing I have to do is sequence item port. Item done. That's all. We are done with the coding. Done with the coding. Only last thing I have to do is I have to go and get this drive transaction code. Line number 15 to 27. Y12. Just paste it here. I have instantiated the drive transaction. I have defined the drive transaction method. This completes my memory driver code also. This completes my memory driver code also. I can run everything put together now. I can run everything put together. Only one small change is required. One new thing is required. I will just do that, and with that, we will be able to finish this simulation also. I mean, another 5-10 minutes, we will end the session, and with that, we'll end the test bench also. Basically, we have to create something called as memory sequence.sv. Class mem write read sequence extends UVM sequence parameterized for mem transaction end class. The first guideline is what? Extend from the base class. Second guideline is what? Any instantiations. APB transact, sorry, not APB. Mem transaction as TX. In fact, it's not required. This is not required at all. Because there is inherently present. You have to register it to factory, UVM object utils, mem write read sequence, mem common. We are going to define one more thing called as object. It will require only name only. It won't require the parent. So since it's an object, see, sequence is not a component, it's an object. You have to call new obj. Then here I have to define something called as task body, end task, UVM do request, mem transaction. This next 5 minutes, whatever I'm going to explain, I'll be explaining again in the next session. Don't worry about this if you don't follow everything. UVM do with doing a write to memory. So since I'm doing write to memory with constraint, I'll use request dot write read equal to 1. Here what I'm going to do is do with same line. I'm just going to do read to the memory, write read equal to 0. Only other thing is request dot address is equal to transaction dot address. So just making sure that I'm reading to the same location where we did write. Reading to the same location where we did the write. That's all. My sequence is also completed. The only last thing I have to do is in the go to the mem test, I have to define something called as run phase. In task mem write read sequence, you just call it as write read sequence. You create that sequence, new of write read sequence, face dot raise objection. See, these all things are completely new. I'll explain to you this concept as we go forward. For now, just understand drop objection. You just have to call write read sequence dot start nv dot agent dot. That's all. We are done. Our test bench is set up now. Now all I have to do is I will have to create a in the top.sv, top tb.sv. I have to include all the files. To include all the files, what I'm going to do is I'll just say ls star sv or ls star sv. So just get all these files. I'm copying all the files as a lines. After ls-ltr, everything got listed. Come here, just paste everything here. Visual block, I'm selecting everything. Okay. This I don't need to include because I'm already in the same file, so I don't need to include that. Interface I included. Okay. Hello everyone. Just 5 minutes. We'll wind up. Last topics like why we created test, why we created sequence, why we created, how we started everything. I will explain everything again. Okay. I'm just trying to show you how to set up one complete UVM test bench, and it can be done quickly. So as I said before, environment should be just before the test. Agent should be just before the environment. Common should be above everything, and sequencer driver sequence, this all fine. Now one thing pending is we have mem transaction in our SV environment. We had mem transaction. The same thing, you call it as mem transaction.sv here in UVM also. Now only one change you have to do: extend this from UVM sequence item. First guideline. This is the first guideline. Second guideline is declare all the ports things. The third thing is register it to the factory. How do you register it to the factory? UVM object utils mem transaction. You may be wondering, sometimes I'm using component utils, sometimes I'm using object utils. If it is a sequence and transaction, I use object utils. If it is a driver, sequencer, monitor, I will use component utils. Then I have to do one more thing here: begin, end. Pick UVM field int addr UVM all on data write read. Then if I do this, I don't need any of them, because just because we did this line, just because we did these lines, this automatically taken care. I don't need to define this manually. The point is, just because I did this, this is happening automatically, so I can remove that code also. That's all. Now my whole test bench is completed. Now all I have to do is go to the top DB, include mem transaction, and I just have to compile it. Now to compile it, let's understand how to create run.do. The first thing remains same: vlog top db.sv. One thing I have to do is I need to include directory where the UVM source code is present. For that, again, what I will do is I will not do everything from scratch. UVM where anywhere you go, factory run.do. I'll just copy this piece of code. This scripting is not required for now. Let's not complicate it too much. Okay. All these options won't be required. Let's just keep it very simple. Test name, all that won't be required. This would be sufficient. Add wave is also, yeah, we can do that. Add wave. And other than that, top DB we should include the memory, because we are using the memory, right? We should include memory.b. That's all. Now I can run this. vsim ampersand. So compilation is done. One or two issues are there. Let's resolve those things. With that, we should be done. Memory. There is, sorry, memory v. These parameters, right? So let me do one thing. y2, go to mem common. Somewhere I'm using macros. I'll have to keep this macros. I think in our test bench we would have done it in the SV test bench. Mem common. Yeah, these two macros. There's only one last thing. APB agent. I'm using APB agent. I should use mem agent in the mem environment. APB, just change it to mem. Mem common not found, line number 25. Line number 25 of TB, line number 25. This is not required actually, because no need to read the test name, that happens automatically. Line number 28, this is also not required for now. Okay, line number 46, there is a problem. Let's just finish off 46, there is a problem. Run test. What is the problem? Near identify. Okay, I got it. I should put it in a double quote. Okay, line number 5, there is a problem. If I go to mem transaction, okay, see, the new object is missing. I have to do new object definition, right? That I missed here. So this completes the overall compilation elaboration errors. There is one thing I need to do. I'll just go and add DUT to the wave. Just do run -all. Simulation has run. And if I go and check the waveform, what you should notice is you are performing a write to the memory here. You are performing a write to D4 location, and you're reading back data. You're reading back the data. It is so happening that the read data is not matching. We'll debug that part. But what you should notice is at D4 you're writing and D4 you're reading. The read data is not matching. Now, why is it not matching? We will debug later. For now, understand that what we have done is in our test bench environment, we have created something called a sequence, write read sequence. We have connected this, we have established this connection. Through the sequencer, we are giving item to the driver. The driver is driving the transaction and writing to the memory. In the second case, you are giving read transaction. This driver is driving and it is reading the data. But read is not happening properly. What is meant by read not happening properly? I wrote this data, A1DF, but that A1DF is not coming. I see that A1DF is not coming. Now, most probably it is happening because I ended my simulation immediately. So I will have to do one small change. It is mostly because I have to give some delay here. Now it will go through. Because I didn't do any delay, so there the problem came, top TB DUT. Okay. The run.do top underscore TB. I run now. Yeah, do you see now it's matching the right data? Is it matching with the read data? Can you see that? You can see A1DF. It's matching with A1DF here. Okay. So there are few things which we have done very quickly. I will explain all those things in a later session. Right now, just remember that till this point you must be clear. Till mem agent you must be clear. Then we started coding sequencer. Then we started coding driver. Coding sequencer is also pretty straightforward. Tab new mem sequencer. Not mem sequencer. Mem sequencer. Very straightforward. Okay. Coding mem driver is also, what you have to do is, first guideline is extend from the base class, define the elements, register to the factory, function new definition, build phase. Then in the run phase, we are getting the item. This isn't something really new for you. We'll explain. It is similar to calling mailbox.get. Okay, it is informing that I am done with transaction. This is common code. This is what we had done in system verilog. Now, who will give the item? That item is coming from mem sequence. Item is coming from mem sequence. This is like I'm creating the right transaction, creating right transaction. Here creating, below creating read transaction. How do I say that right transaction? Because write read equal to 1, write read equal to 0 makes it read transaction. And I'm reading to the same location. Because of that only, my D4 is matching with D4 here. Okay. Now, then in the test case, the important thing that happens here is I am telling that run this sequence on this sequence. Run write read sequence on env.agent.sequencer. I'm telling that whenever we run this sequence, it should be run on this sequencer. This line is a bit complex. You probably will need some time to comprehend this meaning of this. For now, just remember that what is happening is we are running this sequence. Now the next question you may ask is what is rise objection and what is drop objection? I will just explain that. Okay, it is like I told you one thing that in system verilog we used to give dollar finish. You remember in system verilog we used to give manually dollar finish. Now we don't need to do that. Even if you don't give it, it will work. Reason is this rise and drop objection will automatically, whenever drop objection happens, simulation will end automatically at this point. Whenever my simulation reaches this line, automatically it will happen. That is why you are raising an objection, you are dropping an objection. So if you do that, this dollar finish will not be required at all. So with that concept, this is how my test bench is looking like. So if you ask me overall how many files did we develop? We developed this many files. Totally how many? Around 10 files we developed. Okay. So next 2 days or 3 days, you will be working on the same activity. For next 2-3 days, you will be working on the same activity as part of the lab sessions. One more thing I want to tell is there are a lot of new things you are coming across, like what is meant by this rise objection, what is meant by drop objection, what is meant by sequence dot start. Then you may ask, why did you give this 50 units time? The reason we gave is without that 50 units, my simulation was completing exactly here. Then I increased. See, this is 55 units. Now you see it's running till 105 units. Because I gave that 50 units, it got extended. Okay. There are a lot of new things, of course. I told you the same analogy, right? When you are going to learn this software, when the architect is going to learn this software, he's going to find difficulty because he need to understand what is this, what is this, what is this, everything. That will all look new for him. But eventually he will get used to it and he will be able to develop very good architectures by using this concept. So same thing you need to remember. Initially, you will find difficulty with UVM, right? Initially, all the terms will initially all UVM terms will be new. After few weeks, after 1-2 weeks, you will get used to it. It's just about you have to overcome that 1-2 weeks of difficulty. Okay. So that's about it. We will end the session. Any questions before we end the session? Okay. So thank you everyone. We'll end. I did purposefully everything quickly last part because I just wanted to complete and show you. The reason is it all took 1 hour or probably 1 hour 15 1 point something 1 hour to set up whole test bench. You should reach same level. That's the goal. We'll end the session. Thank you.